I mean, with artificial intelligence, we are summoning a demon.
Tiger uppercut!
Come get some.
Come quietly or there will be trouble.
Oh boy, we're gonna have a swell time tonight.
Hail to the king, baby.
Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. Got a fascinating topic for you today. I've been wanting to talk about this particular topic for about 2 years now in a little bit more detail. However, I found it difficult to really find a really good example of how we could use existing Boring Company technology and apply that to some kind of settlement or colony on Mars. And I've been thinking about it more recently, and I thought, you know what, let's just make a video and kind of apply what I've learned through my basic research to the problem. So I'm going to call this a realistic guide to tunneling on Mars. Frankly, I am not a tunneling expert. However, I understand the core basics that are required to make this viable, both from a construction perspective and from a cost perspective as well. So, as you can see, here is Mars. It's a very dusty, dry, cold planet. However, it is full of resources, full of potential. It is a real fixer-upper of a planet. Now, one thing I'm going to say before I start this, we're not going to do some kind of terraforming on Mars for many, many, many hundreds of years. And you've got to work with what you've got there. So I think that you're going to be stuck in the area which is within about 800 miles of the equator. And the vast, vast majority of settlements, if not all settlements, will be within that region. And you have many craters such as this. So there's plenty of places to choose from. But more importantly, you want to find a place where you've got the resources that you require. And maybe, just maybe, it might look something like this. Now, I've thought about this quite a lot. I don't think that it's going to look like this for several decades, if ever. Because building all these structures requires resources being shipped from Earth and then assembled here. And then maybe things might, go wrong with that. So you might have to ship new parts. So it's difficult. It's difficult to kind of really see this as a realistic kind of setup for any colony, no matter how much money you put into it. However, I can visualize something a bit more like this. However, again, there's a lot of things here that require resources from Earth. Most importantly, these are massive domes. These domes require a hell of a lot of glass, a hell of a lot of, steel, aluminium, whatever you intend to use. Certainly you could have inflatable structures, and I very much encourage that, but you're very much limited by the size of inflatable structures. So you want something that's physically solid, that you could import from Earth, some kind of prefabricated structures. I think they would look more like these domes here. You'd have panels, and then you would assemble those panels on Mars, and a couple of the panels would have windows in, but mostly not. And you'd have these assembled by some kind of automated system, or potentially some people living on Mars, because they did have time to do this kind of thing. But once that's all been established and you've got a base that's kind of self-sustaining, at that point you could start to think about going underground. Excuse me. So a lot of people, when they talk about this topic, certainly on X, formerly Twitter, they kind of visualize this where you have hundreds of TBMs digging hundreds of tunnels that are interconnecting each other, and then people would live within those particular tunnels, and it would be this massive underground settlement with thousands, well, let's say dozens of layers, going miles deep. Well, I just don't see it exactly like that, because you've got to be realistic about these sort of things. So For an established colony, so a colony that's more than 10 years old and it's, you know, self-sustaining and it's got a growing, thriving population, it's got the wealth of intelligence and knowledge is available there, and the labour, then you could justify beginning an underground tunnel network. So it doesn't require you to pull resources from Earth and ship them in multiple rockets, and then you have to assemble them, and that probably requires, you know, specific skills and resources like welding and adhesives, and it's difficult. I mean, it's doable. You certainly start off like that. That's probably the safe option, but I think there are other opportunities as well. It doesn't necessarily mean that you would stop doing that the second you started drilling underground. You'd probably do both things, but you'd kind of move more towards having things underground. So I could see a scenario where you'd have 40% of your base above ground and then the other 60% below ground. So the good thing about being underground, it offers superior protection from radiation and micrometeorites. So micrometeors, pretty rare. It's not really an issue, but I put it down there because it will happen. But certainly radiation is a big problem. So you want to be shielding yourself from radiation for at least 16 to 20 hours a day, depending on how old you are. But being underground, you've got 25 meters worth of earth in between you and the radiation. That reduces radiation almost to zero, so that's good. Stable temperatures. The deeper you go, the more stable the temperatures. But even just going 20 meters down, you start to see temperatures really kind of stabilize. It could be, viciously cold outside, minus 30 degrees Celsius, minus 50 degrees Celsius, and you could be in your tunnel, as it were, with minimal heating, and it could be well above 15 degrees Celsius. So it certainly helps. You don't require massive amounts of insulation, massive amounts of heat. Unlimited horizontal expandability. You could keep going, round the circumference of Mars if you really wanted to. Even in mountainous regions, it actually makes sense to start at a low point and then go underneath areas of high elevation, and then you could potentially even go up as well as down. So super bonus. So this is the controversial bit of this. I understand the Boring Company has got a unique solution, and for certain use cases, particularly transportation and moving resources, particularly water and things like that, I think on Earth, that solution, the Boring Company Prufrock system, is incredibly useful. I think on Mars, if you're thinking about building huge networks of tunnels, I would use a different solution. I've been thinking about this for years, and although I can visualize a way of using Prufrock for building, massive interlinking tunnel systems, I think there's a better way of doing this. And it uses less resources and it's a bit more flexible. So what are the most low-cost, flexible, productive means of tunneling? So I've kind of set those three measures of how I'm going to establish which system of tunneling is best. So we have kind of four systems basically. One of them I've ruled out straight away. So drill and blast. It's too dangerous. There's too much risk involved, and there's too many materials that are required from Earth for me to consider that as viable. I actually really like drill and blast in terms of use on Earth for building reservoirs, for mining, that kind of thing. But for now on Mars, I'm going to rule that out. We have TBMs, tunnel boring machines. We have roadheaders, which is kind of a mobile kind of system using a rotating head, but a very small rotating head. And pipe jacking, or pipe jacks, which is very, very similar to TBMs. The only difference is that the outer kind of concrete segments or concrete walls of the tunnel are built prior to pushing the TBM forward, and it kind of grows with the TBM. Whereas the front of the TBM is always building new tunnel lining, as it were. And pipe jacking tends to be less than 2 meters in diameter. So it's limited in terms of its maximum diameter as well. So what system is viable for transport to Mars? Well, you know, TBMs can weigh anywhere from 80 tons all the way up to 3,000 tons. So it's going to require a lot of resources to bring a TBM to Mars. Not that it's impossible, but to kind of do multiple tunnels like we want to do, you're going to need at least 3 or 4 TBMs, and that's going to require, you know, potentially 20 different rockets. So straight away, that's an issue. Pipe jacking, you know, pipe jacks weigh anywhere from, you know, 40, 50 tons all the way up to about 500 tons. So again, you know, very, very heavy. Road headers, on the other hand, you can get a road header machine that weighs less than, you know, 5-6 tons. They go all the way up to hundreds of tons, but you don't necessarily need a big one. You know, you could have multiple small ones. So again, you know, there's a degree of flexibility there. Can it be scaled to construct multiple connecting tunnels? Well, like I said, you know, you need multiple TBMs. TBMs are very, very heavy. Not sure that's possible. Pipe jacking, again, although it's not as heavy, you still need multiple units. It's a little bit faster than TBMs, but, you know, you still have to physically turn around the pipe jack. Same goes for the TBM. Whereas a road header is physically mounted on tracks. It can move in your mine from different tunneling sections, so it's incredibly flexible, and you can have, you know, 15, 20, maybe even 30 road headers all operating at the same time on various parts of your tunnel, connecting them all up. What is the best cross section of underground city? So with pipe jacking and with TBMs, although there are some TBMs that have different shapes, but it becomes very, very complex to do something that's not circular. You are stuck to a circle. And a circle, in terms of, you know, utilizing a circle for whatever you're using it for, whether that's industry or commerce or housing people or running experiments, it's not the most efficient cross section. Whereas a road header, you could literally create whatever shape you want, any shape you want. So you're going to create essentially an arch with a flat bottom. What system requires the least maintenance? Well, TBM's massive amount of maintenance. Obviously, you know, you're going to be maintaining it at least 2 hours every day. Pipe jacking is slightly less, but you're still talking 1 to 2 hours per day. Road headers, again, is a big piece of machinery. It's going to require maintenance, but you might only need to look at it twice a week. So for me, it's fairly obvious what solution we're going to go for. So if it were me, I would go for the road header. So let me just show you something very quick. Okay, so here are our 3 options. We have our road header here, TBM, tunnel boring machine, here, and we have 2 pictures of pipe jacking. Now, I'm not saying that we couldn't use these systems, but I think if we're on a planet where there's limited resources, there's limited labour, and there's limited time, because you have to do a lot of things that you don't usually have to do on Earth, like physically make sure you don't die, you know, I think this is the best option. Now, this is a very big road header, but I've just used this picture because it's a good example. You'd probably have something that's half the size of this, if not a third the size of this, and then you'd have 20 to 30 units, and you'd have it constructing a cross section that's similar to this, although maybe a bit more like that, a bit taller. And you could break this into 4 or 5 different pieces and then ship it on different rockets, or you could put one of these in one of the rockets and then have some low volume items in that particular rocket, so you're not wasting space. There you go. So this is a better picture. This is something that will really kind of visualize it for you. So we have our shaft that goes to the surface. Obviously, this area is all pressurized. So, you know, it's going to be earth pressure down here. People are going to be able to walk around. Now, they might necessarily be in machinery, but it will be pressurized. A lot of these processes will be fully automated. You just have someone walking around supervising things. You'd have some kind of office or somewhere where you can go into, and it's fully pressurized and is safe if something does go wrong. But the spoiler would come off the back here, and then you'd have some kind of automated dumper truck system. You'd probably need 4 or 5 dumper trucks per road header, and then this spoil would be collecting up top, and then every week or so, you kind of open things up, and then you dump that on the surface there. But that in itself would be quite difficult, but it's doable. So the disadvantage of a road header is that it's going to be a lot slower than the TBM, and a lot slower than pipe jacking. Remember that there are pipe jacking machines operating today that are getting over 100 meters per day, and there are obviously TBMs that are getting well over 40 meters per day. And you'd think that Prufrock at this stage would be getting towards 70, 80 meters per day. So a road header, maybe if you're in ideal conditions, somewhere in the region of 12 to 15 meters per day. But the advantage is that you would have 20, 25, 30 of these machines of varying sizes. Some would be 60 tons, some would be 20 tons, and they would be operating in various parts of the system. And when you add that up, you should hopefully be able to do way over 200 meters per day theoretically, although the kind of limiting factor is getting rid of the spoil at the end, because you're going to have to dump that on the surface, which means you're going to have to depressurize the tunnels, and then you're going to have all your dumper trucks essentially removing what they've already moved. But I could visualize a system like this easily doing 800 meters, maybe even 900 meters per week, with a sizable number of dumper trucks and road headers. In terms of our ideal cross-section shape, it would look something like this, maybe slightly more curved, but it would look like this. And then you've got a flat bottom, and there's lots of space down here which you can use for whatever purpose you're going to do that, whether that's going to be a factory or some kind of residential facility. You could have multiple levels in a tunnel. So you could have transport at the bottom, and then you could have people living above, or you could have two, it could be like a 2, maybe even 3-story house. You could have another level up here as well. Because theoretically you could make this 30 foot tall if you really wanted it to, but I think in reality you'd have it where it'd be about 24 foot wide, and then maybe about 26, 28 foot tall, something along that lines. And then you'd have connecting tunnels, which should be a lot less than that, maybe 14 foot wide by 18 foot tall. So just before I kind of try and explain how you would do that the best way. So imagine this as like your drone view. So you're above the settlement, the colony, and you're looking down at the network of tunnels. If you could see through the ground like X-ray vision. As you can see, the red tunnels are artery tunnels, so they'll be used mainly for transportation. You'd obviously have pedestrian, footpaths, that kind of thing. But mainly it'd be kind of the roads of the colony. And then the green areas, residential, maybe a bit of industry in there as well. So you'd work and you'd manufacture things in the same area. So you'd have mostly residential tunnels. And these obviously, you'd have a corridor that would be fairly narrow, and then you'd have like some kind of steel structure in there. Again, that would be pressurized, and if there was some kind of air leak, you'd be able to shut it off. So you'd be able to section off different tunnels if there was an issue. The blue would be like a commercial district, so you'd have like bars, restaurants, like retail areas, places where you could get electronics, things that you get repaired. But one of the interesting things is this light shaft, which I'll explain in a moment. So our main shaft, which is here, would be at least 25 meters deep, and then everything, the whole shebang, would be on one level. We're not going to go multiple levels down, because that's adding complexity. To make this work with a road header, it needs to be stable strata. So you need medium to hard rock. Ideally, you'd want something like medium hardness that you can easily dig through but supports itself, ideally. And then you would ultimately come across cracks and fractures in the rock, so you'd use anchor bolts, which are fairly lightweight, and you wouldn't need to use that many. You wouldn't actually need a tunnel lining if you use the road header, because you'd be able to shape the cross section to ensure that it doesn't collapse in on itself. But in some cases you need to use anchor bolts, which look like this. They're about 2 to 3 meters long, and then you would obviously fire them into the walls of the tunnel, and then you'd either inject a resin before or after, and you can inject resin in there to fill various cracks and things like that. So you're using what is already there, you're not importing materials. This here is a means of constructing vertical shafts. So you start off with the kind of the cutter head at the base, and then it goes up, and then the materials fall down into the existing tunnel. So you could use something like that to create light shafts. And I really like light shafts for the colony, because people don't want to be living in the dark. If you're living in tunnels, the last thing you want is, you know, a dark and dingy environment. You want places you can go where there's lots of greenery, there's lots of light, and you could use mirrors to focus light on the surface into these areas and make them appear like oases, basically. So I've put here 2 light shafts. I'd imagine they'd be about 16 meters in diameter, and they go up to the surface 25, 30, 40 meters. So to get your stable strata, you'd want to go way down. I've said 25 meters. You might have to go 30, 40, maybe even 50 meters to find the strata that is useful for digging through, which requires almost no structural support, or very minimal structural support. So there you go. That's what potentially what it looked like. Here is our kind of vertical boring machine. This would be on the surface of Mars. You'd have to close this off, and then, you know, otherwise the air, it's going to suck the air out. And then once you've done that, you'd have to line it and then construct some kind of dome on the surface there. But I can imagine things like this. This is obviously like a natural kind of light shaft, as it were. It's formed naturally, but I can imagine this is how it would kind of look. And then you'd have trees at the bottom and shrubs, bamboo, you know, flowers and things like that. And it would be a beautiful area where people would all come together and congregate. And you know, it would be a place where you meet people, and it would produce, you know, a nice environment for the colony that's not dark and dingy, because that's the main issue with doing things underground, is that you're stuck in an area like, you know, like this basically, but without the light. But this looks lovely. So what about Proof? I know you probably think, well, this channel's about Boring Company and Prufrock. What about Prufrock? Why don't we use Prufrock? There's got to be something we can use Prufrock. And yes, we can certainly find a use case for Prufrock, but we're not going to have hundreds of machines. We're going to have maybe a dozen machines that are operating on Mars, and we're constantly refitting them, and we're using them for a specific use case. So if we set up a Mars colony on 2040, I really hope we do, but I don't think we will. I think it'll be 2045. A TBM like Prufrock wouldn't be required until 2056. However, in the long-term future, we will be using Prufrock a lot, because Prufrock is extremely fast, and we'd expect Prufrock to achieve way in excess of 80 meters of tunneling per day in one direction, maybe even 100 meters per day. So it will tunnel to various mines and help establish new colonies. So there will be new colonies that establish from time to time. I expect that as more and more resources are found, you know, old colonies might close down and new colonies will form around where the most resources, the most people are, and then they would spread out in kind of like a star shape. These tunnels that Prufrock would build would be for transport, because that's what, you know, Prufrock is good at building transport links. And I believe, strongly believe, that these would be almost like freight networks They would be used for passengers, but mainly for moving essentially freight, so materials, supplies, resources between colonies, between mines. And I'll show you how they do that in a minute. The surface is a dangerous, unpredictable, cold environment, so the more things we can put underground, the more transport that we can do underground, the less risk we have, because when we're doing things at the surface, there's always a high level of risk, and that results in more cost and obviously more delays in terms of doing things. Prufrock would be engineered and sent in 6 packages. So I'm saying that if Prufrock weighs a few hundred tons, if you include the back end of the machine, then you would have one section in one rocket, another section in another rocket, and then you could use up the maximum space in that particular rocket. Maybe use less dense items in there, and it will be sent in six packages basically. So one obvious change would be a 17-foot cutter head. So the current cutter head for Prufrock is less than 14 foot. I'm saying that when we go to Mars, we were going to want these freight corridors to be very high capacity. You probably want a broad gauge railway as well. So you're looking like a 6 foot 4 inch gauge for the railway. And to make that fit, you need something close to 17 foot. You might get away with 16 foot, but why not make it bigger? The material that comes out the back end you can use for other things, or it can just be dumped at the surface, so it doesn't really matter if you have excess material. And here's how it would look. So I've imagined 2 colonies. So Colony A arrived in 2040, and then in 2050, Colony B was set up as kind of like a much smaller colony because there were lots of resources around there. That resulted in this grey line here, which is a kind of freight connection between the 2 colonies. Allows passengers and mostly freight to travel in between the 2. And then we have various mines that we have found in this area. Some of them are massive mines covering areas of 6, 7, maybe even 8 square miles. Others are much smaller mines, maybe less than 1 square mile, and they contain important resources that we all need. And then obviously Colony B was set up. We have aquifers. So the reason Colony B was set up because there's a large aquifer here. And then it's just so happened that we found some other resources within 5 or 6 miles. So if you're building a tunnel that's more than a mile long, you cannot go wrong building it using Prufrock. But if you're building lots of little intricate tunnels connecting each other in this kind of crisscross sections, then you would use a road header, and you'd have 30 road headers all operating at the same time. They'd all be autonomous, and you might have maybe like 3 people supervising 30 road headers and 100 dumper trucks, and all that would be basically you're just supervising, making sure that it's fully automated, because it'd be basically controlled by AI. You might not even need people down there, but I'm assuming that people want to be down there just making sure everything's going okay. All these resources obviously would come to Colony A, they'd be refined, and then any materials or products could then be sent over to Colony B. Colony B would then expand greatly up to around 60,000-70,000 people, and then at that point maybe there'd be another tunnel going over here to Colony C. Maybe there was another aquifer over here or some kind of water source that was 50 miles away, and rather than doing that at the surface with a road, you'd have a tunnel, and that would all work out quite nicely. So that's kind of how I visualize it. I know it's been a long video, but there's a lot of basic concepts to discuss. Hopefully you can put that in the comments below if you have ideas or suggestions or things that you thought that I said that were wrong. Please let me know. I'm happy to talk to you about that. Surface roads, I imagine there would be surface roads, and there would be massive like road trains like this. So you'd have huge 3, 4, 5,000 ton road trains like this, and you'd have roads, but again this would be fully automated. You wouldn't have many people in this at all. It'd be just too dangerous, and it would move fairly slowly, maybe 20-30 miles per hour, because how would you construct a road out here? It'd be very difficult. You just have compacted stone basically, whereas if you're in a tunnel, you could have a full-on freight train, and that freight train could be going down there, 80, 90, maybe even 100 miles per hour, and it could carry more stuff, and it'd be safer. You wouldn't probably use a Hyperloop to begin with. You'd want something extremely basic, so you just go back to using existing freight, technology. It's just that the gauge of the track would be much more like around 6 foot 4 inch gauge. And there you go. That's the idea. Let's use road headers instead of using TBMs for the actual base itself, but to move in between bases to connect up mines and things like that. To provide transport links, we would then use Prufrock. So I hope you enjoyed that. Please like and subscribe if you've not already done so to the channel, and comment on the video. That always helps with engagement. Please do that. Anything you can write in there, I don't care what it is, positive or negative, please tell me. These are various ways you can connect with me and help support the channel: Twitter, Discord and Patreon. Very much appreciate this support on Patreon. It's been very helpful recently. I had some issues with the Mac, and I managed to get them resolved, fortunately, using money that I'd got from Patreon. None of it ever goes to waste. None of it is ever spent on, random things. It's only spent on this channel, on this GoPro camera, on this incredible microphone, on the lights, on this desk, all spent using your Patreon money. Thank you very, very much. You've done an incredible thing for me. I do appreciate all your financial support. And yeah, hope you enjoyed it. Thank you very much for engaging. And remember, guys, don't be boring. Hopefully, one day, we'll be there. And hopefully, I'll still be alive. We all hope so. Because what a day it'll be when we land on Mars. Wow, it will be just amazing. I can't even imagine it. Okay, guys, see you on the next one. Goodbye.
Perfect.
I mean, with artificial intelligence, we are summoning the demon.
Surely you can't be serious.
I am serious. It's time to kick ass and chew bubble gum.